Welcome everyone. So this is our 79th live stream geometry. So we're getting closer to 100. And we have two people here with us now. And today I'm going to go over more problems that were posted on AOPS by the user RopuToran. So he or she has posted some really nice problems in the past. So I've used a couple of them in my last sessions, and I'm going to do some more this session. So if you want to join us in the future, if you want to join our geometry session, feel free to email me at mgreenb801@gmail.com. It's in the description of my video, and we meet every Sunday at 8 a.m. US Central Time. All right, so I'm going to share my screen, and we will get started on the first problem. So here's the first problem. I think these might be maybe slightly easier than previous weeks, but they don't seem that easy. So we have a triangle inscribed in a circle, and D, E, and F are the feet of the altitudes. So there's the triangle. Here's the circle. And O is the center. Now I'll draw the three altitudes. All right. And I might as well draw the orthocenter too. So this is D, E, F. We'll draw the orthocenter later after I draw a point G. So then what we do is we draw the circle. Let me make it look a little nicer. That looks better. So then we draw the circle centered at A and passing through D. And it meets the circle O at points P and Q. And then PQ intersects AD at G. So this is P and this is Q. And PQ intersects, oh, what is J? I think this might be, let's see. Oh, I know what G is. Wait, PQ intersects AD at G. I think they forgot to write in the problem, but I think J is where EF intersects AH. Let me check that. Or maybe they had it written in the problem, but I didn't copy it right. Yeah, that's J. Okay. So this is J. Yeah, this problem looks a little easier, but we'll see. I'm going to draw these points just because they might be useful, because the reflection of H over each side lies on the circle. Yeah, I don't know we're going to need all these points, but I'm going to draw them anyways. It looks like PQ is parallel to EF. I don't know if that's obvious, or let's see if that's actually true. Yeah, it looks true. So yeah, I'm going to take the problem. So PQ intersects AD at G, and EF intersects AD at J. There we go. So that is the problem. Let me try to make it so that these doesn't overlap the problem, if possible. Passing through D. There we go. Something like that. So is it obvious? So EF is anti-parallel to BC, but is it obvious that PQ is also anti-parallel? Let's see. Yeah, those definitely look parallel. So yeah, BFEC is cyclic. Well, let's see. BFEC is cyclic and BPQC is cyclic. So maybe it's obvious from that PQ is parallel to EF, right? Is that just like Rimes' theorem? They're both perpendicular to OA. Oh yeah, that's true. Yeah. So that proves it. All right, so we know those are parallel. Okay, so RP and Q are collinear, you're saying, because if R is the midpoint of LB, wait, if EF intersects BC at L, okay, so all right, I'm gonna call this something else. Call it Q. Okay, so this will be L, and then R is the midpoint of LB. And okay, so I think you've solved it, right? Yeah, it seemed like an easier problem. So, whoops, sorry. Okay. I'm going to copy what you put. All right. So let EF intersect BC at L. Let R be the midpoint of LD. All right. Okay, so RD squared is RB times RC. That's because those are in harmonic conjugation, like you said. And that means that, oh, whoops. It should be Q. This should be, I'll call it X. So since RD squared is R B times RC, basically that means it's on the radical axis of the two circles. Circles. Okay, and RD squared is RB times RC because L, B, D, C are in harmonic conjugation. Okay. I'll just say AB, BE, and CF concur, and that means that those are in harmonic conjugation. All right. So yeah, that's a quick solution. So just one more line, and then I'm going to move on to the next problem. So once we know that, then so since LR equals RD, then we have JG equals GB, and that solves it. So, all right. So, hey Con, thanks for joining. That means JG equals GB, and that solves the problem. All right, so this is a fast one. Let's see. We have a lot of people from Vietnam here today. Hey Con. And
yeah, Ma Trung is actually my friend too.
Okay, very cool. So yeah, thanks everyone for joining. This is cool. So yeah, hopefully all the problems won't be this easy, but let's see. Oh, this one looks kind of cool. Let's see if you guys, I'm not sure if you guys have seen this problem before, but it looks interesting. So basically you draw the phi to the altitude, and then you draw the incircle of that triangle. So they call it HA, HB, and HC. Let's see. A lot of people from Vietnam today. I love it. Whoops. So this is HA, and then HB and HC. And then we draw the incircle of that triangle. So let's use GeoGebra. So we have the incircle of HA, HA, HB, and HC. What? Why did that not work? What did I do wrong there? So I'll try one more time. Incircle of HA, and then HB, and then HC. There we go. And then D, E, and F. Okay, so this should be, the touch points are D, E, and F. And then we draw tangent lines to that circle. So yeah, it's like a pretty small circle. So let me see if I can draw things a little better. But basically the pole of A is supposed to be the midline of triangle DEF. So let's see. So yeah, it might be easier to rewrite this problem. Basically, I think maybe a better way to do it is to draw the midpoints of DE and DF and show that they lie on the polar of A with respect to this circle. So we have these points, but then if I draw the midpoints of DE and DF, so that's I and J, basically we want to show that these are all collinear. So I'm gonna call these M and N because that's what it was in the problem. And so yeah, that's not collinear with J. So maybe I should move things around so it doesn't look like that's true. Oh, or is it collinear? Wait, is that obvious that B, is it obvious that J lies on the altitude from B?
Yeah, it is, because we have HAJ is the angle bisector of HCHBHA.
Because this is the angle bisector of AH, or so this is the angle bisector, and the midpoint of DF. Oh yeah, it has to lie on the angle bisector by symmetry because yeah, H. Okay, so that makes sense. So yeah, it makes sense that those are all collinear. I guess I might as well draw this too, right? Interesting. So yeah, because it's well known that H lies on the angle bisector of this HCHBHA, and also, yeah, clearly the midpoint of this by symmetry lies on the angle bisector. So yeah, that proves that.
I think I have found a way to solve this one. I think it's not really that hard.
Oh, really? Okay.
Yeah. So can you draw a circle with a diameter AH?
Okay.
Maybe I will save some time for the hard one. So I'll be solving this one fast.
Okay.
So we will show that I lies on Mn. Yeah, I lies on Mn. So which means I lies on the radical axis of DEF and in that circle.
Okay.
So
Now,
we
do
have
we know? So so angle AMH, because yeah, okay, H is the end center of this triangle. So yeah, okay, I see what you're saying. Okay.
So we have the power of I, which respect to DEF is ID square.
Okay.
Yeah, and it is equal to IH times IHC because of the right triangle.
Okay. Okay.
So I lies on the radical axis and similar to J.
That is a very fast solution. Okay. All right. So maybe I will look for some harder problems. But yeah, thanks for sharing that. So so H is the end center of HAHBHC. So first of all, I'll start out by saying this. So HBB bisects angle HAHBHC. So that's well known. So H is the end center of HAHBHC. And then from there, J, so I'll just say label the points as shown. Yeah, so so J is the midpoint of DF. That means that H, B, J, H, and B are collinear. I'll just say similarly for the other sides. And then once we know that, then angle HMA is 90 degrees. So HMA is HNA is 90 degrees. And that implies that AHCM, so, yeah. And then MHNHB is cyclic. And then, so IHC times IH is ID squared. That's ID squared, which is ID times IE. So I mean, that's true because angle HDHC equals 90. So and so I lies on the radical axis of the two circles. So does J. I think it's point J, right? So does J. So M, N, I, and J are collinear. And that implies MN is the midline of DF. All right, let's try to find a harder problem. So, oh, Nguyen has a different solution. HC lies on the polar of I. So AHC is the polar of I. And similarly, A lies on the polar of J. So IJ is the polar of A. Oh, that's an even easier solution. Yeah, that probably would have solved it even faster. Interesting. All right. So let's see if there's a harder problem I can find. So yeah, I put a lot of problems here. So that one might be too easy. This one looks good. We'll see if this one's harder. I think this one might be. So triangle ABC is in circle O. And then we have a circle passing through B and C. and it intersects AC and AB at E and F. So this should be F. I'm going to draw the centers later. So we have BE intersects CF, and that's point D. And then P is the intersection of AB and BC. So this is P. And H is on AO. So here's where I got to draw the centers. So this will be O and O prime.
Isn't a small circle supposed to pass through C?
Oh, you're right. You're right. Yeah, that's my bad. The small circle should pass through C. Okay. So glad you caught that. So this should be E, and this will be F. So BE intersects CF at D, and this is going to be point P. And then we draw the two centers. This one and this one. So yeah, so this is perpendicular to BC. So H is on AO. Okay, so O prime H is perpendicular to AB. So basically, we draw the perpendicular. So I'm probably going to want to draw this full line. So yeah, let me draw this point on the circle. Wait till this goes away. Whoops, I didn't mean to do that. Flows out of that. So that'll be G. And draw this point. Let's call it something different. Call it K. Okay, so O prime H is okay. So I want to see where these intersect, AO and OK. So this is H. And I is the midpoint of OD. And we want to show that PI bisects AH. All right. So I guess I could draw the midpoint of AH, and I want to show, this looks a little like the Gauss line kind of. So I is the midpoint of OD, J is the midpoint of AH, and I want to show that these are collinear, I guess. So I guess the picture was kind of better before. Yeah, like this. Okay. Interesting. So yeah, O prime is perpendicular to BC.
I think we can you connect EF?
EF.
Yeah. So I have an idea, but I don't know if it's gonna work. So I wanna ask you guys. So yeah, and can you label the intersection of AD and EF? AD.
AD. Sure.
Yeah. So by Menelaus, we need to prove that PD times PA times IO over ID times JA over JO equals 1. So
Okay.
we know that PD over PA is MD over MA. So maybe we can try to prove that MJ is parallel to OD.
Okay. Yeah. No, that makes sense. Yeah, we want to show it. By Menelaus, we want to show MJ is parallel to OD. That seems easier than, yeah, the original problem. And almost, is pH also parallel to them? Or I don't know. It almost looks like pH is parallel to both of them, right? Let me check that that's actually true. Oh, it's not. It just looks like it. Because if I move F around, yeah, that's not true. So yeah, those are parallel, but yeah, pH is not. Yeah, I like that you use the harmonic conjugation. So yeah, you use that. Yeah, PD over PA is MD over MA. It's a good idea. Can we use Brocard? So I guess Brocard's theorem would tell us about like O prime D, but not necessarily about OD. One sec, I'll be right back. All right, thanks for waiting. So we want to show that I wonder, what if we try something like this? I wonder if this is the midpoint of AM. Let's check. Huh, yeah, it does look like it. Okay, so what if we try something like this? Oh, whoops, what did I just do? I'm gonna hide, I don't want to hide all of that. I just want to hide this line. So it looks like if N is the midpoint of AM, then it looks like JN is parallel to O prime D. Maybe that's obvious, I'm not sure. Because J is the midpoint of AH. And O prime D, I wonder if these concur. So if we draw EF, BC, and this, no, those don't concur. So basically MH is MH, it seems like MH would be parallel to O prime D. Is that obvious? So yeah, there's a lot of interesting things here. I don't know if I need to draw this whole circle. Actually, let me see. Yeah, what happens if I let EF and BC intersect? Is there anything special about that point? I don't think so. Oh, maybe that point lies on KH? Yeah, okay. So that, we have to prove that, but that looks like it might be helpful.
Sorry, but what did you say we need to prove?
Oh, that EF, BC, and KH are concurrent. I don't think that will solve it, but that's just
that is true to due to Brocard.
due to Brocard.
Since by Brocard we have O prime is the orthocenter of ADQ. So
Okay.
we have O prime Q is perpendicular to AD.
Okay, so it passed through H. That makes sense. Okay. So yeah, so O prime is the orthocenter of ADQ. So basically we want to show M is the midpoint of AK. We know that D is the orthocenter of AO prime Q. I wonder if G, well, let's see. Okay. All right. So let's see. So OD prime is perpendicular to AQ. And I think we could also try to show that HM is perpendicular to AQ. So I wonder if AHQ is isosceles, actually. No, it's not. But is M the orthocenter of AHQ? I think so, right? Yeah. So basically, I think I can show that MH is parallel to O prime D because D is the orthocenter of AO prime Q, and M is the orthocenter of AHQ. So yeah, so these are parallel. So MH is parallel to O prime D. And I don't know if that can help us show that MJ is parallel to DO. Because then we know AM over MB. We want to show it's AJ or JO, but maybe we could use these parallel lines somehow. And then, yeah, NJ is parallel to. Okay. Let MH intersect AQ at U. Okay. So U is the foot of the altitude. and then O prime B intersects AQ at V. And it looks like that's on the circle, right? Okay. So this will be V. So V lies on the big circle and U lies on the smaller circle. So hold on. So you're saying MJ, we know we can show MJ is parallel to DO because a homothety so J, what is the circle J? Is it like, is it this circle? Okay. Diameter AH. So homothety at A takes this circle to that circle. Let's see. Okay, so this kind of looks like the power ratio. So then we have AU over AV is AJ over AO. And that would also be AM over AD, which would prove that those are parallel. But how did we show, let's see. Did we prove everything we so I guess for this solution we don't need point Q, right? Or maybe we still should have it, but
I think we use it for Brocard, so let's keep it.
okay. But okay, so basically I just wonder, is it so we know, like, if you drop this perpendicular, so HM intersects AQ at U, right? How do we know that? Okay, because AUH is AKH is 90, so we know AUKH is cyclic.
We know AU is perpendicular to AQ because M is the orthocenter.
Because M is the
AQH.
Yeah. So we know AUKH is cyclic. And then for then we're saying a homothety. How do we know the homothety that takes that circle to the big circle takes U? I guess I'm just trying to think of everything that we have to prove. So
because like we know A is the center of homothety taking J to O, right?
yeah.
So any line passing through A and it meets circle J at U and circle O at V, it must be that U and V are are also homothetic.
Okay. So yeah, so that pretty much solves the problem. Okay. All right, that makes sense. So I'm going to type it up. Okay, so we're going to use Menelaus. I'm going to do the Menelaus in the very end. So by Brocard's theorem, so let EF intersect BC at Q. Yeah, this one wasn't that hard either. So yeah, maybe I can still find a harder one. And then by Brocard's theorem, O prime is the orthocenter of ADQ. So and similarly, like M is the orthocenter of AHQ. And then from there, so let H, so let HM and O prime B meet AQ at U and V. Well, first we want to show that those are collinear, but that. Okay, so first of all, this means that Q, K, and H are collinear. I think I should hide G and N. Okay. Yeah, I think that makes sense. So all right. Hey, Robbie. Oh, did you join yet? Hey, Robbie, thanks for joining. So we're on the third problem. So yeah, they've been a little easier today. So I'll try to find a harder one. And yeah, thanks for creating the contest. So I don't think I'll be able to participate just because I don't know if I have the time, but I'll look through a couple of the problems and keep trying them. But yeah, I hope a lot of people participate in it. So, all right. So we have M is the orthocenter of AHQ. So let HM and O prime B meet AQ at U and V. So P meet AQ at U and V. And then we know AUKH is cyclic. So first of all, angle AUH AKH equals 90. So that means AUKH is cyclic. So by a homothety at A, that means that AV So I'll say it with center J. So AU over AB equals AM over AD. Well, it's going to be AJ over AO. But then also, we know it's equal to AM over AD. So that means MJ is parallel to DO. So by homothety at A, taking the circle J to the circle O, we have, let's see, I'll say VU over VA. VA, that's equal to OJ over OA. And then we have, I'll say DM over DA. So we use the homothety for the last part here. And then this means that MJ is parallel to OD. So yeah, actually, I don't think I need this, right? Oh, no, I want that just because, yeah. This, and now we can use Menelaus. So then we want to show that PI and J are collinear. So we want to show PM over PA times AJ over JO is equal to 1. And sorry, I forgot. Oh no, we want to show that PM over PA times AJ. I'm getting confused. We want to show HJ over HA. Oh no. Oh, we want to show that PD over PA times AJ over JO. Oh, but then we use the harmonic conjugation. Okay, so that's where I kept getting confused. So, so basically, AD and P are in a harmonic conjugation. That's what I kept forgetting. So that basically means that PD over PA is equal to MD over MA. So an MD over MA is equal to JO over JA. So that means that, let I be the midpoint of OB. Then now we use Menelaus. And there's probably a way to do it with just cross ratios, but I will use Menelaus. So we have PD over PA times AJ over JO. JA over JO. And then OI over IB equals 1. And then that means that PI and J are collinear. And that means that PI bisects AH. All right, that was a fun one. Did I ever define J? And I don't think I did, so I'll just say let J be the midpoint of AH. Then I'll move on to the next one. So yeah, we're flying through these. All right. Very nice. Let's see. So there's this problem. This one looks kind of interesting. So we have a triangle with orthocenter H, and we have a line that passes through H. So I feel like this is kind of so that's H. We want a line through H, and we want it to intersect AC and AB at Y and Z, such that HY is equal to HZ. I feel like I've seen this idea before. Is there like, I don't know if we can use something with some medians to figure out how to draw the line.
We can construct this using harmonics.
Harmonics, okay. So what's the right?
You draw the altitude from B and C?
Yes.
Let's label the feet of the altitudes.
Is E and F okay?
And so we'll let EF meet BC at a point.
Okay.
And let them meet at D. And then we draw the line through H and parallel to AD.
Okay.
And, that is the line that we need to construct.
Okay, so it's parallel to AD. All right. I think, there we go. And let's see, why does that work? So this should be Y and this should be Z. So AH is a median of that triangle. So basically that means, oh, I think I know why that works, because basically if we draw the, well, actually maybe I'm not so sure. Okay, so you said harmonics. Oh, because we have h, y, z, h infinity. If you project through A, you get B, C, D, and the foot of the altitude. Okay, so that's why it works. All right. You probably wrote that in the chat. Let me check the chat. Okay, but yeah, that makes sense. Okay. So, you know what? Let me call this D right here. So I'll call this G, and call this D. And let me okay, let me first draw the rest of the problem. So we draw the intersection of Y, Z and the circle HBC, and that's T. So this is basically the reflection of the circumcircle of ABC over BC. And that point is T. And then we draw the perpendicular from T to BC. And we want to show that AX, BY, and CZ concur. So I don't know if we can use Cheva here. Let's hide a bunch of stuff. Basically hiding almost everything. And then I'll draw it back. So this is parallel to AD, or to AG. And there we have it. Okay, so we want to show AX, BY, and CZ concur. We can use the butterfly theorem. So HM, M is the midpoint of BC. Oh, you're saying that's another way we could prove it. Oh, I like that. Okay. Yeah, it is nice. Because yeah, BFEC is cyclic. And so by the butterfly theorem, if those concur, yeah, that is nice. Yeah, that's a very simple way to do it using the butterfly theorem. Okay, so now let's see if we can use Cheva's theorem to solve this. Let me check that it's actually true. So we have AX, by and cz. Oh, so yeah, it's true. And it almost looks like tx, but yeah, that can't be true. It just looks in this diagram like tx and be meet on the circle. Maybe that looks a little better. Yeah, this is so weird, like taking a perpendicular from T to BC.
I think we can find a way to use it.
Oh yeah?
So I'm just predicting. So can you let YZ meet BC at a point?
Yeah.
So we know that AX, BY, and CZ concur is equivalent to saying that cross ratio YX, IX, BC is equals to -1,
Yes.
right?
Yes.
So let project from T onto the circle HBC.
Okay.
So can you let TX meet the circle at a point?
Yeah. So we have HBC. We want to show that's a harmonic quadrilateral, basically.
Yeah, exactly. That is my idea. I don't know if it works.
Sounds good. So we want to show HBJC is harmonic. I wonder, is GH tangent to this circle? No. But yeah, those tangents should concur on BC. All right. Yeah, that seems like a good idea. Trying to show this cross ratio is 1. So yeah, if this were 1, yeah, what could we project through?
Can you draw circumcircle of ABC?
Yes.
And can you let it meets AG at a point? AG,
Yes.
yeah, right there.
This is cyclic.
So if the problem is true, then TX must also pass through K.
TX must also pass through K. And I think KH and M are collinear, right?
Yeah, exactly.
Interesting.
But can you just connect it? So maybe I'm wrong or yeah, it's true.
Yeah.
So this is because of like we have HBJC equals -1, and I will do a reflection over BC. J will be
Oh,
K and B, yeah.
that's
But
creepy.
we haven't known that we haven't known that HBJC is a harmonic yet.
Yeah, we have to show that. Yeah, so maybe I'll draw this point. So yeah, we're trying to reflect across BC, because then it would be the same as showing that KBNC is harmonic. And I think, is that like well known, or that's probably easy to prove, right? HM, okay, yeah. So this point, so yeah, JL is parallel to BC since THX. So HJ is a symmedian. So like THXM is cyclic. So JL is going to be parallel to BC. So HJ is a symmedian. So basically, if HJ is a symmedian, then we know HBJC is harmonic. So yeah, that solves it. Interesting. Okay. Yeah. So yeah, that solves the problem. Another, yeah. So there are harder ones that were posted by RopuToran. So
I'm sorry, but how is HJ the symmedian?
how is H? So HJ is a symmedian in triangle HBC because basically HL is the median, right? And angle LHC is equal to angle JHB because JL is parallel to BC. So these lines are basically isogonal. HL and HJ are isogonal in triangle BHC, right?
Oh, okay, I got it. I got it.
Yeah. So that solves it. Let's see.
So we actually don't need K.
Okay. So yeah, do we need G? I don't know if we need G. I don't think so. Okay, so first of all, yeah, so BF, so I'm going to start out saying what we know. So BFEC is cyclic, and then by the butterfly theorem, or the converse of the butterfly theorem. So we have BFEC is cyclic with center M. So HY equals HZ, and so So basically by the converse of the butterfly theorem, H is the midpoint of the chord of BFEC through Y and Z. So I'll write that by the, I'll capitalize the butterfly theorem. We have H is the midpoint of the chord of BFEC through Y and Z. And that means that HM is perpendicular to EF or YZ. Okay. Yeah. So, oh, there's a faster one. Since THMX is cyclic, they're both equal to IT and IH. So IX times IM is IB times IC. Oh, does that prove that those are harmonic? Okay. So that one's super fast. So I'm just going to write that one. So THMX is cyclic. We have IX times IM is IB times IC. Yeah, which is IT times IH. Yeah, that's really fast. So yeah, so we don't need all those points. So okay. And then, so since M is the midpoint of BC, we know that those are harmonic. Yeah, I like it when we have more than one solution. It's cool. So then we have this. And so basically that means AX, BY, and CZ concur. So we had two solutions to prove this part, and then we had two solutions to prove this part. Yeah, they're too easy. Let's see. So I actually, there's a couple harder ones that I found. Like I think this one is kind of hard right here. So let me think about it. So that one's too easy. Yeah, some of the harder ones so yeah, this one was surprisingly hard. This is the one we did on the session last week. Let's see. This one looks kind of hard right here, right? So yeah, let's see if we can do, we could like try spending the rest of the time on this one, see. But yeah, sounds like he's probably.
It is this problem is Le Viet-Ang, right? He's a very famous teacher in Vietnam, and his problems are really hard. Just
Really,
like
really hard.
Buratino.
You think this one might be too hard?
It's okay. We can try it. We can try it.
Okay.
Because there are many Vietnamese participants here, so let's try it.
Let's try it. Okay. All right. So, All right. Whoops. I think that's, you write his name. Sorry about that. So yeah, I think this might be like a generalization of the Newton line or something.